Now let's continue by looking at the first example Now here it says state whether the following numbers are rational, irrational, or neither. So we have 5 questions here that we are going to look at, and then we also identify whether the first one is it rational, irrational, or neither, as well as the second one up to the 5th one. Now let's look at the first one together. How do we then go about telling whether the first one is a rational, irrational, or either? So 1 here. Then number 1, we've got the first one, since it is 0.25, so 0.25 it is a terminating decimal. Okay, terminating decimal. Therefore, the terminating decimal is under rational. Okay, so that is the perfect answer for the first question. That is a rational. Okay, why? Because it is a decimal. Why? Then number 2, we want to look at the negative number. So the negative number, so it is known as an integer. Okay, so remember that negative number. So also it's under irrational, because integers are under rational. Okay, rational. Why? Because it is an integer. Right, and then number 3, let's look at this one, pi plus 6. Pi plus 6. Okay, so is it pi plus 6 rational, irrational, or neither? For the fact that it's having pi here, pi, so it's under irrational, because pi is under irrational. Okay, so that means now the irrational plus rational, because 6 is a what? Is a rational, and then pi is a irrational. So the sum of irrational plus rational is always irrational. So that means the perfect answer is going to be irrational. Okay, why am I saying this? Because sum of irrational and rational, so it's always irrational. It's always irrational. Okay, now let's look at the 4th one together. Number 4. So also this one, for the fact that it's having pi, so that means it's quite clear that it's also under irrational. Okay, so that means the perfect answer is gonna be what? Irrational. Irrational. Why am I saying this? Because any fraction of an irrational is irrational. Because any fraction, this is why, please forgive me over my handwriting. Any fraction of an irrational, so is what? So it is irrational. Okay, Yeah, now let's look at the fifth one together. That is the square root of 9 over 16. Square root of 9 over 16. So please, boys and girls, do not confuse this. So this is the square root of 9 over 16. But this one, it is a square root 9. It is a root 9 over 16. And then this one, it is 9 over square root 16. Okay. So this one, it is a square root of 9 over 16. And then this one, this is a root 9 over 16. And this one, it is 9 over square root 16. Okay. So now let's look at the first one. So I'm not going to write the sum here. Remember, we're writing only answers. So then the answer is, since 9 and 16, it is a perfect square. So perfect square is under rational. So that means the perfect answer is going to be what? Rational. Okay. So why am I saying this? Because 9 and 16 are perfect squares. 9 and 16 are what? Perfect squares. What? They are perfect squares, and let me continue by saying and the square root of 9 over 16 is equal to 3 over 4. Okay, so if it is equal to 3 over 4, then which is a fraction? Which, let me start by saying which is a fraction. Okay, so that is all. That is the first example of this lesson. Now let's continue and we'll look at the second example. Wonderful. Now let's look at the second example of this question. Now let's look at this one together. Now example 2, now it says, show that the following numbers are rational. Now we'll be looking at the two questions here. The first one says 0, 1, and number 2, 1,75. Okay, let me just rewrite this. This is 5, and there's a dot here. Okay, so these two dots, we call them recurring. So it shows that it's recurring. Okay, now let's look at this. The first one, how do we go about answering the first one in showing that this number, it is a what? It is a rational. Now the only thing that we are going to do here is that, so we're going to in fact, let's just write this one as it is number 1, and that is 0, 1 recurring. So now we're going to let this number equal to x. That is, let x equal to 0, 1. So that dot means recurring. So that means this number is repeating after the comma. So we'll no longer have 1 that is a digit or singly value after the comma, but many 1, 1, 1, 1. So how many? 6. Let me just add 1, 7. So it could be 8, it could be or maybe 4 or 5, it doesn't matter. Okay, so now that is the first step that you need to do when you are proving or showing that this number, it is a rational. So that dot means recurring. So that means you repeat that digit many times after the comma. Okay, then now the second step here is to multiply by 10. So we use 10, 100, and 1000 so to solve this. But the first thing you need to do, you need to use 10 first. So if 10 doesn't give you the same digits after the comma, you use 100. If same applies with 100, then you proceed to 1000 up until you have the common digits after the comma in those two equations. Okay, so now what do we do here? So we're going to multiply by 10. Multiply by 10 in both sides. Okay, so this is what we're going to do here. So we're going to say 10 times x, so definitely it's going to be 10x, and 10 times this number here, definitely it's going to be 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me check if it's 9 really. Yeah, it's 9. So, but you can prove that by pressing this number in your calculator. Okay. So if now you see that these digits after the comma same as these ones, nothing different here, and then you simply separate the two equations together. This is equation number 1 and this is equation number 2. So there is no need to proceed to 100 as well as 1000 if these digits after the comma are the same. So the reason for you to proceed to 100 to also multiply by 100 is because you are trying to make these digits be the same after the comma. So ours here are the same, so that means we just multiply by 10 only, then we proceed. So what we're going to do here is that is to subtract. So the next step, what do we do? Let me just use another color to, so these are the steps just to guide you. So let me put a second one here. Okay, please don't write this one in the exam, I'm just showing you now. Okay, so now the only thing we're going to subtract equations 1 from 2. Equations 1 from the second equation. Okay, that is the step that I'm going to do now. So let's do that. So this is the first equation, this is the second equation. So what I'm going to do here, I'm going to take the second equation and minus the first equation. So let me write that one down here. So I'm going to say 10x minus x. So remember, so you take these digits on your left hand side, you separate them here on the left hand side as well, and those that are on the right hand side, then you also multiply, you also separate them on the right hand side as well. So we're taking the second one, we separate the first one, so it's going to be 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, recurring, minus, so that is the second equation, and minus the first one is going to be 0, how many? 1, 0, 3, 6, 7, 1, 2, 3, 4, 5, 6, and 7, dot, dot. Right. So now we say 10x minus 9, minus 1, sorry. Remember there's 10 here, there's 1 here. So 10 minus 1, definitely is 9. That is 9x. And then now we take this one as well. We subtract 1, 1, 1, 1, 1 minus 0, 1, 1, 1. Then we get the answer. So the answer is going to be 1, 0, 0, 0, 0, 0, many zeros there. Okay, because of having 0 as the first digit after the comma. So, and then that means we're going to take only this, only the numerical value. Okay, only the numerical value. Now, so we're going to have 9x is equal to 1. And we simply divide by 9 in both sides because we're solving for x. So it's going to be 9 here and 9 on that side. So therefore 9 will nullify this 9 and we're left with the x is equal to 1 over 9. So that 1 over 9, it is a fraction. So this is what we were proving here. And then we conclude here by saying which is a fraction number. So 1 over 9, it is a rational number. How do we know that? Because it is a fraction. So therefore, or let me just indicate here, x is equal to 1 over 9, and then which is a fraction. Right. Or maybe we can say it is a fractional number. Yeah, I can just put it in that way because it is a fractional number. Okay. Fractional number, right. So we've done now proving the first one. Now let's go together again and proving the second one. Wow. Let's continue. And then we are now showing that is the second question, that these numbers are rational. So we're going to use the same method we used in the first question. So firstly, we're going to let x equal to this number, which is 1, 75, 75, 75, 75. Right. So how many 75 do we have after the comma? 1, 2, 3, 4. So it can be 5, it can be 6. Okay. And then now remember, in the first one I said, so you have to multiply by 10 first. But if 10 makes these numbers or digits after the comma not be the same, then you proceed to 100. Okay. So let's quickly look at that one together. Let's first multiply by 10 over here. So 10 times x is going to be 10x, and then must be 10 multiplied by 1.75, and then here is going to be 17, 57, 57, 57, 57, dot dot dot. All right. So this one, it is the, and this one is known as the first equation, and this is the second equation. Right. Then how do we then proceed here? Okay, just before we go to 100, let's look at our digits after the comma. Are they the same? Let's look at our digit in the first equation, and we compare these ones together with the ones in the second equation. Right. So it's going to be 75, 75, 75, and 75. But in the second one, we've got 57, 57, 57, and 57. So that means they are not the same. So definitely we have to multiply by 100 now. So when you multiply by 100, that is the second one. So what do we do when you multiply by 100? Now I was saying, then now we proceed to 100. Okay. Then now when we multiply by 100, we are not going to multiply by 100 in the second equation. No, we are going to multiply in the first equation. So let's go together. So 100 times x, so it's going to be 100x is equal to, and then 100 multiplied by this number is going to be that is a 175, comma, must be 75, 75, 75, 75, dash. So that means now you can clearly see that this one is known as the third equation. So you can now clearly see that the first equation and the third equation, they share the same digits after the comma. So it's 75, 75, 75, 75, and 75, 75, 75, and 75. That means now we are done. So now we are going to subtract equation 1 from 3. Okay, so let me also note that one. So we're going to subtract 1 from 3. Okay, so now when we subtract equation 1 from 3, so that means I am going to say 100 minus x, 100x minus x, right? And then we take this one here, 175, 75, 75, 75, 75 minus, or let me just also add the dots here, minus. And then we also take the first one, which is 1,75, 75, 75, 75, and dot dot. And then we separate the two. So 100 minus 1, 100 minus 1, definitely it is 99x. And then we also separate these ones on this side. So they're going to give us, remember, 175 minus 1 is going to be 174. Because these ones here, they are going to cancel each other because they are the same. Okay, so that means we're going to have 174 because 5 minus 1 is 4. Okay, remember we're solving for x. So what do we do then? Then we simply divide by 99 in both sides. This will nullify, therefore x is going to be, which is 58 over 33 or 33. So we are done here. Then we just conclude by saying which is a rational number. So this is a what? Which is a rational number. Okay. Yeah, so we are done now. Thank you so much. Now let's move on to example 3. Now example 3 says between which two consecutive integers do the following irrational numbers lie? Between which two consecutive integers, okay, do the following irrational numbers lie? So now they are telling us that these are the irrational numbers. These ones are the what? Irrational numbers. If you can see all of them, they are not perfect square. So it's quite clear there. But now they're asking us to identify only the two consecutive integers. Okay. Now let's take the first one and we see that how do we then go about finding these two consecutive integers. Okay, so what are we going to do here is that we have, so in the first one we have 12. So this is what is given to us. Now let me tell you this, in order for you to be able to determine the two consecutive integers between this irrational number. So what I'm going to do here is that you must find the two perfect squares integers. Okay, so that means we have to look the number that is a perfect square from 12 going down to 1. Okay, the first number that you're going to find, which is a perfect square, so then it is that number that we're looking for. And then same applies again, you are looking for a number from 12 going up to 100, but you must find the first number from 12 and the first number going down from 12 again. So, and then those numbers we are looking for the perfect squares. Okay, I know that after 12 there is 11, but 11 it is not a perfect square after 11 there is a 10, and 10, it is not a perfect square. Okay, so that means you must keep on checking the number which will be the perfect square from 12 going down and from 12 going up. Okay, so let's check. After 12 we have 11, we have 10, and 10 and 11, they're not perfect squares. And then we have 9, and then 9, it is a perfect square. So don't even waste your time continuing to 1. Okay, once you find the first number from 12 which is a perfect square, then you use that number. Okay, and then same applies from 12 going up. So the first number which is a perfect square, then it is that number that you are looking for, right? And then so that means here we have 9, sorry, my marking pen here, I don't know what's going on. We have 9 less than, so we have 9 less than what? 12. 9, it is less than 12. And now let's check another number from 12 which is a perfect square going up. We have 13. 13, it is not a perfect square. We have 14, it is not. We have 15, it is not. But there is 16. Here we go. Then 16, it is a what? A perfect square. So that means we should stop right over there. So that means we're going to use 9 and 16 as the two consecutive integers. Right. Thank you so much. Then now we simply square root everything here. So it's going to be the square root of 9 less than the square root of 12 less than the square root of 16. Okay, so this is how, guys, you find the two consecutive. Then what is the square root of 9? Definitely it is 3 less than 12. Okay, please don't do anything here. Okay, this is what you are given. Then you are trying to find two consecutive integers. Okay, where this number, which is root 12, lie. And then now it's going to be less than, then the square root of 16 definitely is 4. So that means now we have found the two consecutive integers. Okay, and then you just conclude now by saying therefore 3 less than then you conclude by saying therefore square root of 12 the square root of 12 lies between 3 and 4. Yeah, simple as that. So it's easy. Now let's look at the second one. Let's look at the second question. Guys, my apologies, I don't know what's going on in my camera. It's faint. Yeah, but make sure that you listen attentively to what I'm saying here. And then now when we look at the second one, guys, we're going to do the same here as we did in the first question. So what I'm going to do here is that again I'm going to look for the two, in fact for the number that is less than 12, which is a perfect square, again counting from 12 going down and counting from 12 going up. So definitely still this one's going to give me 9 and 16. Okay, so now we simply say, guys, I want you to pay attention to this one while I'm doing this one. So it's going to be 9 is less than 9 is less than 12 less than 16. So this is what we have here. And then now we continue by saying, we know that if I'm going to square root in both sides, then I'm going to have 3 less than the square root of 12 and less than 4. Less than 4. As if I'm going to square root here, square root of 9 is 3, the square root of 16 is 4, and the square root of 12 is just root 12. Then we conclude now by saying that now we interchange the inequality, because here we are having the negative, so it's going to be a negative 3 So if now we have negative 3, if we divide by negative 3 on both sides, so this inequality sign changes. If it is less than, it's going to be greater, negative 12. If it is less, it's going to be greater, minus 4. Okay, so this is how, guys, you do this question. Yeah, then we are done now. We have found two consecutive. Do the rational number lie on, so that this is the first one and this is the second one. Okay, so now we conclude by saying, therefore negative root 12 lies between. So guys, please make sure that when you write these two consecutive integers, you start with the smaller one. Which one is smaller than the other one? There is minus 4, there is minus 3. Definitely minus 4 is less than minus 3, or is smaller than minus 3. Okay, minus 4 and minus 3. So you start with the smaller one and the bigger one. So we're done, guys, in the second equation. Now we move on to the... Then again, let's look at the number 3 together. I don't know what's going on in my camera. Okay, guys, I've used a bigger font here so that you will see clearly that this is the cube root of 20. Okay, now, guys, the procedure is the same. The one that we used in the first question is to look up the numbers from 20 going down. Okay, which when we cube root that number, it must give us the whole number. Okay, and then for example, after 20 there is 19, but when you say the cube root of 19, the cube root of 19 cannot give you a whole number. Instead, it's gonna give you a decimal numbers. Okay, so then now you check 18, even 18, and even 17, even 16, 12, and so on. So you keep on checking, as long as that number, when you write that value here, then it's gonna give you a whole number. Then you take it, that number, but from 20 going down. Okay, then we keep on checking 10, 12, and so on. So the perfect number is going to be 8. And the cube root of 8, then it's quite clear that it is equal to 2. So that means that we are going to use 8. Okay, so guys, we keep on checking here, and as well as from 20 going up, then let's check any number that if you can write it here under the square root when there's a cube here, then it must give you a whole number. Now, so let's check after 20, there's a 21, it is not, 22, 25, 26, and 30, definitely it is not. But if now we check 20, the cube root of 27, the cube root of 27, definitely that one is going to give you a whole number, which is 3. And then that means these are the two consecutive integers that we are looking for. Okay, so that means we're going to use the two ones, that is 2 and as well as 3. Okay, so now let's check that how do we then write this one down. So I'm going to say 8 it is less than 20, and 20 it is less than 27, right? And then we just cube root everything here. Therefore the cube root of 8 less than the cube root of 20 and less than the cube root of 27. All right, and then now we have already done these two consecutive integers. In fact, we have already checked them, that if there is a cube root of 8, definitely is going to give us 2, and that one is going to give us 3. Okay, so this one we just drop it as it is, you don't do anything here. 20 and less than 3. So guys, we have done now. So the only thing that we need to do is to conclude, okay, by saying therefore Therefore, the cube root of 20 lies between, guys, very, very important, this statement here. Okay, your conclusion lies between, remember I said you must start with the smaller one, so 2 is smaller than 3, so lies between 2 and 3. So we're done. Guys, thank you so much for example 3. Now we move on to example 4, which is the last one. Thank you so much. Now let's look at example 4 of lesson 1. In fact, this is a bonus one because now I wanted to cover everything under irrational, integers, natural numbers, so on. But this is a bonus one. So now let's look at this one. This one says round off the following numbers to the number of decimal places. Sorry, supposed to be 1 of decimal places indicated. Okay, and then now the first one now says 4,31437. So these are the digits that are given to us after the comma, and then now we have commanded to round off to 2 decimal places after the comma. Now I want you to watch this, that how do I then round off into 2 decimal places after the comma. Now, so what do we do here? You simply, so here I'm going to write over here, I'm going to use these spaces as my answers. So in fact, let me just use another color. All right, yeah, so let me throw another arrow. Yes. Then now what I'm going to do here is that I'm going to repeat this 4,31437. This is what is given to us. Now when they say round off to 2 decimal places, so what do you do? After the comma you count 3 digits. 1, 2, 3. Okay, 1, 2, 3. That is the third one. In the third digit, then that's how you are going to run off. Now in the third digits, what do we do there? Let me continue to write the answer. So you say in the third one is going to be 3 comma, oh sorry, there is a 4. It's going to be 4 comma, if this color is not clear. Let me just continue with black. Okay, using black, 4 comma 3 1 only, because they say we must run off into 2 decimal places. That means we must take only 2 digits after the comma. But now listen carefully. So in the third digit here, so what do you do in the third digit? Then you take 1 only if it starts from 5 and above. Then you take 1 in the third one, then you add in the second one. Okay, but if you start from 4 and below, so you don't take anything. So that means you only take the 2 digits after the comma, then you ignore the rest. Okay, then if the third one starting from 5 and above, then you just take only 1 here and then you add to the second one, and then simple as that. But let's look at this one together. Now this one says we must run off into 3 decimal places. This is not December, but this is for decimal places, or same here, guys. Okay, then so let's write this one down, and then we begin to round off. 1, 2, 3, 4. How many 7? 5, 7 here. So when they say 3, then you count how many digits? 1, 2, 3, 4. In the fourth one, when they say 3. When they say 2, 1, 2, 3 in the third one. Okay. So now here, what do we do here? Our answer is going to be 1, 7 and 7. So in the fourth one, we're going to take 1 here because starting from 5 and above and 7 is more than 5, so, or 7 is bigger than 5, so that means we're going to take 1 here and then we add here in the third digit. So remember 1, 1, 2, 3. So we're going to take 1 here and then we add here. So it's going to be 1, 778. 1, 778. Here we go. And then now let's look at the third one. 365, 1534. These are the digits that are given to us. And now we have instructed that we must round off into 1 decimal place. So this one is going to be decimal place, not decimal places. Okay, because it's only 1 digit, not places, but just place. Okay. And then now again here we write this is going to be 365, then just 1 decimal place. So this one is very easy. When they say or let me just repeat this one here, is going to be 1, 5 and 5. Also 1, 5, 3, 4. Yes, and then now when they say 1 decimal, then you count how many decimal do you have here? 1, 2, 3, 4. But when they say 1, then in the second decimal, in the second digit, then we're going to take 1 only if start from 5 and above. You take 1 and you add here because they say into 1 decimal. So our answer is going to be 365, then we take 1 from 5 and then we add here. So it becomes 2. What? So now let's look at this one, the last one. This is the last one, 9,998. So how do we then go about round offing this one? We remember having 9999 here. So 9 is quite clear. So when they say into 1, we're going to take only, you see in the second digit here, then we're going to take 1 from here. This is 9, and 9 it is above 5. Then we take 1 and we add here. But guys, I want you to look at this one carefully. So when we take 1 and we add here, it's become 10. And then when I have in 10 now, the rule says you must also add that one to this 9 here before the comma. So we're going to take 1, it's become 10. And once we have 10 here, we must also add it here also. So that means we're going to have 10. So it's going to be 10, which is 10. And we also, if we add 1 here, it's going to be 10, which is 0. So that means it must be 10, 0. So this is our final answer. Guys, thank you so much for watching. Thank you so much. Please don't forget to subscribe for more videos. Thank you so much.